Yeah, I
Yeah.
think so. Yeah, okay. So good morning, everybody. Thank you very much for joining this event virtually. Now we're going to start our technical sessions. First, we have Mr. Shuman Kumar Shah from Pipeline Security. With a vast experience of more than 10 years in the industry, he is going to discuss about DNS security today. He is going to share his experience on how to build our DNS infrastructure threat aware. So, Mr. Sherman, please share your screen with the audience.
Hello. Am I audible?
Yes.
Okay. So should I share my video? Okay. It's showing host has stopped. Okay. Hi. This is Shuman. I'm from Pipeline Security. I work there in my technical team. So Pipeline Security is work to secure, provide secure internet. It's based on Japan and Singapore. So today I will talk about DNS response policy zone that actually help us to secure our network from inside threats in our that is lies in our network. Host not allowing me to share video. Uh, it's showing host has stopped. Yeah, it's okay. I can continue. So as we all know, after coming IPv6, yep, hope you can see me now. So yeah, I can continue my topics. As you know, internet is growing very fast with IPv6, and when it is coming up to connect more devices like robotics, connected car, smart infrastructure, and in IoT, and everything is interconnected is through artificial intelligence in place. So it's doing a complex, going to be a complex infrastructure day by day. It's coming up with a huge functionality. So yes, so it's growing very fast. So network is now a huge, as you were saying, with IPv6, it actually will accommodate like 340 trillion hosts in the network. So that's actually huge. So if we think about security of this huge network from an operator perspective, who are actually need to maintain a huge network, and every network is connected with a huge number of hosts. So it is not affordable to deploy a network firewall to deploy a security in place for the whole network. Now, as we have DNS and BGP is the two most critical infrastructure for internet ecosystem. So, and every domain query actually started with a DNS query. So, and of every, and in malicious activities, over 91% of malware actually uses DNS. And so a domain name system is really important to mitigate those security issues. So as like any legitimate query, in malicious actors also use DNS for their malicious purpose. So So now the DNS response policy zone is the easy way to implement a firewall without deploying any new appliance, without deploying any new big hardware. So now we can actually handle those security threats inside in our network. As we know, DNS architecture is very uh, distributed architecture, and from its 3R model, it has issues on accountability, and complaints are ineffective most cases. So this resiliency and unaccountability is the greater benefit for bad actors actually. So yes, as you see, this is DNS is one of the most important part of internet ecosystem. So everyone actually want to use that for his good and bad purpose. So from the other reports is showing crypto miner actually used DNS to contact with command and control in most cases. If we if we mention WannaCry, there was a kill switch domain too to contact for this malicious purpose. And that was actually a lifesaver for many incidents too. So DNS RPZ actually allows our existing recursive server to control on the behavior of responses of queries. So now we can overlay custom information of the DNS queries that we are getting from global DNS recursive process. And DNS response policy zones is packaged with a reputation data. So we actually integrate reputation data with response policy zones. And response policy zones actually update frequently via IXFR or AXFR, that is actually zone transfer of DNS between master and slave DNS. So in RPZ, it's include both filter criteria and with some response policy zone, response policy action. It's the RPZ actually introduced by Internet Hall of Fame legends Paul Vixie. With him was Shiver was with him. They submitted a IETF draft back on 2010. Till now, it has 4 modifications. So if you have time, you can check the IETF draft. Yes, there can be actually a possibility to misuse from government and regulation perspective. Some people can, as we can overlay the queries, DNS query. So if like government and regulation want to block some domain, particular domain, or they can redirect any domain to another direction, yes, there is a possibility to do that. So yeah, it has both is one is good, another is for other purpose too. So in DNS RPZ, we can take feeds from different feed providers, from different masters. So we can, if we have more data, we have more information about the badness of domains. So yes, we can take data from different feeds, and we can keep our that actually can help the internet. What actually DNS we can block? So we can block phishing, any malicious domain that is based on threat data. So phishing, malware, ransomware, uh, any malicious domains we can block. And most importantly, now we can identify infected machines using this RPG. So if we analyze the RPG logs, we can actually find which IPs are actually infected by which threats. So now we can uh, find the threats, and we can find what uh, who is infected. So how we can implement it actually? So we can implement in our existing DNS like bind, part DNS recursor, not. Unbound has added DNS RPG from its 1.10.0, and we can also use like info blocks, efficient IP F5. All those big vendors also have this technology to block malicious traffic. So this is how actually RPG rule looks like. If we want to block a domain, like a domain name, and we mention CNAME in the zone file, and a dot. Dot actually is mentioned an non-existence domain, that is an X domain. That means now if we want to go to beddomain.net, it will actually answer with a query like non-existence domain. And with response policy, there is some triggers. Mostly we use key name, that is query name. Like when we will query for google.com, that is actually come as QNAME to the DNS server. So mostly we use QNAME, and to the answer we use an X domain. And if we want to put the query answer to a world garden, we can use our CNAME to our intended domain name. That is, we can redirect one domain to another domain with this feature too. And we can also use pass-through to avoid any false positive. So before implementation, what actually I maintained, and I recommend that as it is a firewall, so in logging mode, we can implement fast tweak in logging mode. And it's better if we use TC. And another important thing is in network, some people use the open DNS like Google DNS, Cloudflare DNS. So I actually redirect all the DNS query to my RPG enabled DNS so that I can keep data. So I can keep all the DNS query in this safety net. So where I can get spam house. There are other vendors. So if you can, for details, you can go to dnsrpg.info. So for a case study, if I mention that we used RPG feeds from spam house, we used bind, and we tested with unbound and part DNS recursor too. And as I already mentioned, if you use existing DNS, you can use a forwarder to your RPG enabled name server, so that you don't need to change anything in your current infrastructure. So this is the resources that we need, like bind. For bind, we need one servers, and for visualizations, we need another resources. And we need a feed from a feed providers. So installation is really simple. It needs more than not more than 60 minutes to implement these with bind or unbound. It's with our power DNS recursor. It's very easy. One important thing is with bind, there has a zone limit of 32 zones. So we can use till 32 zones. And this is very simple as a DNS master slave zone transfer. So we are actually transfer zones in our recursive servers for this threat data. And it's important to logging. So in RPG logging, it's important to log RPG and analyze those. So if we see in the log, you are seeing that in a log, we can see the source, who is going to a thread destination, and we can see which thread destination it is. And also we can see what kind of threads it is. So three most important thing actually we can know from this RPG, like we know source of threads, we know destination of the thread, and we know what type of thread it is. And it's we can, if, like every firewall, as we mentioned, we can find some false positives. So in my implementation, I find one false positives to a cryptocurrency sites in the feed. There was a cryptocurrency site, and for those cases, we actually use we have option to whitelist. So if we mention this domain with CNAME and RPG pass-through, that will be the whitelisted in this DNS firewall. So most important thing is we need to have a visibility on our network from threats landscape. What type of threats we have in the network. So analyzing this log, we can have a visibility on the threats, and we similarly we can generate alerts and all those things to keep our system intelligent. So if we see analyzing this log, we can find what are the top thread domains in the network we have. We can find who is the most infected source IPs in my network. So here you will see one source IP is infected by 7,000 malicious requests. So now we have every details of these requests. And we can find more metrics like number of queries, count hourly. So if we anything happen, details like if we see anything more sharp spike on the queries, so it will be we can see there is maybe DDoS is coming or anything. So you can actually use that a very useful way. So as you are saying, with this DNS, actually, we have now visibility on our whole network, what queries we are processing, what is the threats inside. So everything we can understand from this thing. And this is a use case in a Indonesian ISP. So as you are saying, seeing in a we implemented RPG in a 3 DNS servers, as you are saying. Why do we have implemented DNS RPG? Those name servers actually providing better performance with less latency. And maybe I was curious what was the reason. Maybe as it is dropped so many queries, malicious queries without going to recursive process. So it's actually helping DNS to working as more to provide better performance. And you see from this case study, you see there was huge number of malicious requests are there, like for a malicious request, there is millions of malicious requests in the network. So that was those malicious request was behind our any visibility. Now we can actually can see with this DNS RPG that we have this number of threads. Yeah, so this is the takeaway that so after implement that, I actually know that there is actually huge number of cryptocurrency request of cryptocurrency destinations in the network. Before that, I actually have no idea that in our network, too many people actually go to cryptocurrency destinations, and sometimes false positives arise. And yes, we have a way to handle these. And after implementation is by this RPG, we have visibility to our network from security postures. And now we can identify infected source IPs. And with this RPG, now we can mitigate threats from source IPs, and we can mitigate from our own network, and we can keep our network clean. So that's all. Thanks, audience. Thanks, guys. So if you have any question, I'm here. You are welcome. I'm here to answer you.
Thank you so much, Suman. That was brilliant. As you mentioned, we are open for questions and comments. We're going to have to move quite quickly though, so please do get your questions in. We've got one by text. Can you please share the name of the DNS log analysis software, and is this free software? That's from Mahadi.
Yeah, there are some log analyze, like you can use free, like Logstash. You can use Logstash to analyze logs. It's free. So yes, you have that option to use it.
Fantastic. I'm just going to leave the option up for a little bit longer for questions. I just wanted to say, Suman, that it's lovely to hear the Dakar traffic behind you. So if we don't have any other questions, I'm going to throw back to Zabir. Thanks so much.